In this 7th lesson of the Basic Algebra in Full series, we are going to learn everything about algebraic fractions from the very foundation all the way to advanced levels. So if you are ready to cross this hurdle of algebraic fractions, let's begin. The numbers on your screen 0, 1, 2, 3, 4, 5 and so on are numbers that you are familiar with. These numbers are called whole numbers or integers. However, there are values in between one whole number and the other. These values tell us how many portions left before we reach the next whole number. These values can be represented by fractions. Another way to represent these values is through the use of decimals or percentages, but we are not going to go into those two in this series. So from what we've said now, a fraction is one of the ways to represent an incomplete or a number that is not whole. A fraction has three parts. The upper part, which is called the numerator, as we see here, the middle part, which is the fraction bar, or let us call it the dividing line, and the lower part, which is called the denominator. If you ever have a challenge mixing the upper part and the lower part, just remember that numerator has a U, and that U stands for up. Denominator has a D, and the D stands for down. Now, from what we've talked about, you realize that a fraction, just like roots, are creations of the multiplication and division family. This one is specifically a creation of division because this fraction bar is basically a division line or a division sign. So it's telling us that the numerator is being divided by the denominator. So it is basically division. We will see the implication of this as we move forward. On your screen are the three major kinds of fractions. In the first one, the number below or the denominator is bigger than the number above or the numerator. In this kind of fraction, it is just like a bigger person is carrying a smaller person. And this is what is expected, and that is why it is called a proper fraction. In the second type or kind, the lower number is a smaller number, which is a smaller person carrying a bigger person. This is not what is expected, and that is why it is called an improper fraction. In the third type, you are combining a whole number with a fraction. So this is basically 1 plus 2 over 3. Such a fraction is called a mixed fraction because it is mixing a whole number and a fraction. To simplify a mixed fraction, you simply multiply the denominator by the whole number, then you add the numerator to the result. So in this example, it is 3 times 1, 3, then plus 2, 5. So this is the same thing as 5 over 3. And if you notice, what you are getting is an improper fraction. So anytime you simplify a mixed fraction, you always get an improper fraction because of the whole number that is involved in the simplification. Before we go on to discuss algebraic fractions, let's look at simplification of fractions. That is addition and subtraction, multiplication and division of fractions. As we begin, let me remind you again that everything you've learned so far in mathematics, including operator ownership, operator siblingship of families, they are all relevant. Mathematics is connected. We are going to start with multiplication and division because it's not new. It is something we've done before. We did it in lesson 4. There is really no difference. Remember, I told you that fractions are creations of the multiplication and division family, obviously, from what we've seen so far. So multiplication and division of fractions is basically the same thing we did in lesson 4. But we are still going to do it for completeness. Now look at this example on your screen. 2 over 3 times 1 over 6. What you simply do is you multiply across or you cancel out. So this gives us 2 over 3 times 6 is 18. Then when we cancel out 2 here 1, 2 here 9, this gives us 1 over 9. Or you could decide to just cancel out straight away. 2 divided by 2, 1, 2 divided by 6, 3. And if you multiply across, it gives you 1 over 9. That is this times this over this times this. Now, if it was division, as you see on your screen, 2 over 3 divided by 1 over 6. Like we said, this is the same thing as 2 over 3. If we find the reciprocal of this divided by 1 over 6, it gives us times 6 over 1. Then if we cancel out 3 here 1, 3 here too. So the answer becomes 4. Now for addition and subtraction of fractions, look at this example on your screen. 2 over 3 plus 1 over 3. Now to add or subtract fractions, their denominators must be the same for you to add them. Now for this one, you add this numerator 2 and 1, it gives you 3. Then you pick one of the denominators because they are already the same. So you pick one of them. So that's 3 over 3. And that gives you 1 when you cancel out. You've already noted one difference between this addition and subtraction and multiplication and division. If this was multiplication, you multiply 3 and 3 to give you 9. But in addition and subtraction, you pick one of just the 3. But we know that this is not always the case. You don't always have fractions with the same denominator that present themselves for you to add and subtract. Most times you see fractions with different denominators. So how do you do it in such a case? Now look at this example on the screen. 2 over 3 plus 1 over 6. This is a classic case of adding fractions without the same denominators. So what do you do in this kind of case? You have to find a way to force them to have the same denominator. There are 2 ways to do this. The first way is the most common way used everywhere, most high schools or secondary schools all over the world, and that is the method of the LCM. What does it involve? LCM means lowest common multiple or least common multiple. So what you do is you create a framework for your answer by drawing the fraction bar, and then you write the denominator you want. That denominator has to be a multiple of 3 and 6. If you recall lesson 5, when we talked about multiples, we said multiples are the times table of any number. Now if you see this 3 times table here, 3 times 1, 3 times 2 and the rest, and you see the 6 times table below, you see that here we have 6. 3 times 2 is 6 here, and then we have 6 times 1 is 6. This is a common multiple. So 6 is a common multiple of the 3 times table and the 6 times table. And it's not just a common multiple, it is the lowest possible common multiple of these 2 times table. That is the 3 times table and the 6 times table. So that's the meaning of lowest common multiple or least common multiple or LCM. So it is this 6 that we will write as the denominator. Then we go ahead and say 6 will be divided by this 3 to give us 2. Then that 2 we get multiplied by this 2 that is in the numerator will give us 4. Then we put this plus here. This 6 again will be divided by this 6 in the denominator here. It gives us 1. Then that 1 multiplied by this 1 above gives us 1. So it will now solve as usual. 4 plus 1, 5 over 6, and that becomes the answer. Now let me mention here that most times you will not be able to get the LCM as fast as you want to, especially if you are dealing with big numbers or when we enter algebra properly and you have a variable as the denominator. It's impossible for you to know what the LCM will be since you don't even know what that variable is in terms of what value the variable represents. So in such a case, the best way to do it, which is what most people do, is to multiply these 2 denominators. Why are you doing that? And is it different from LCM? Not really. Now look at this times table again to understand this better. If you look at the 3 times table, at some point you will get to 3 times 6. In the same way, at some point in the 6 times table, you will get to 6 times 3. So if you use multiplication of the 2 of them, which is 3 times 6, and you put 18 as your denominator, you will not be wrong because we know that 18 is a multiple of 3 as we've seen here, because definitely if you check the times table of 3, you will definitely encounter 3 times 6, which is 18. In the same way, if you check the times table of 6, you will definitely encounter 6 times 3, which is also 18. So 18 is a multiple of both 3 and 6, but it is not the least common multiple. It is not the least multiple, but it is a multiple nonetheless. So it is also correct. The only thing is that when you get your final answer, you have to simplify further. This is the easiest way to approach this, especially when you don't know the LCM or when the numbers are too big or when the numbers or whatever it is involves variables that you cannot find the LCM at that moment. So let's solve it completely using this method and see if we will get the same answer we got initially, which was 5 over 6. So if we put 18 as the denominator, which is a multiple, although not the least multiple of both of them, we do the same thing we did. 18 divided by 3 gives us 6. Then 6 times 2 gives us 12. plus 18 divided by 6 gives us 3. 3 times 1 is 3. So this gives us 12 plus 3, which is 15 over 18. Then if 3 divides both of them, we have 3 divided by 15 gives us 5. 3 divided by 18 gives us 6. So as you see, we got the same answer. So anytime you are in doubt or you don't know the LCM or you are not sure what the LCM is, just multiply the two denominators and use it as your denominator. When you now get your final answer, you can now simplify further to get a simpler form of your answer. Now we will go to the second method of how to force the denominators to be the same. We will use the same example just to make it clear and to be sure we will get the same answer. Now in this second method, what do you simply do? You multiply one fraction by the denominator of the second one. So what we are saying is we are going to say 6 times 2 over 6 times 3 plus 3 times 1 over 3 times 6. What did we do here? We just ensure that these denominators are the same. 6 times 3 and 6 times 3, so that we can now add across as we said initially. Now for those wondering, by doing this, are we not changing the question? We are not changing the question. This 6 that is up and down, if we cancel it out, it still gives us 1. So what we are doing basically is we are multiplying this fraction by 1, but we are now using 6 over 6 as a technique to make the denominators equal. In the same way, you are multiplying 3 and 3 up and down on this side. So you are not changing the fractions, you are just using a mathematical technique to make it easier to simplify. So when we simplify further, 6 times 2 gives us 12, 6 times 3 gives us 18, plus 3 times 1 gives us 3, 6 times 3 gives us 18. Now we are now in a setup where the denominators are the same. So we just simply add across 12 plus 3, 15. Then we pick that 18. Now if we simplify it further like we did before, 3 will divide 15 to give us 5, 3 will divide 18 to give us 6. You see that the answer is the same. This particular method is very, very useful, especially when we get to algebra. This particular method is very, very handy. So you need to know this method as well. Now we are going to take one more example of this basic fraction simplification using addition and subtraction. The example we will use now will involve more than 2 fractions, and we also have the subtraction operator involved so that we can see how it works and be sure our method still works. Now look at this example on your screen. 1 over 2 plus 1 over 3 minus 1 over 6. Now let's use the first method. We find the LCM of these 3. It is 6, because if you check the times table of 2, 3 and 6, 6 is the least common multiple. 6 will be divided by 2, 3. 3 times 1 is 3, plus 6 divided by 3 gives us 2. 2 times 1 is 2, minus 6 divided by 6 gives us 1. 1 times 1 is 1. So if you solve it, it gives us 3 plus 2 is 5. 5 minus 1 is 4. So 4 over 6. If we simplify this, 2 into 4 is 2. 2 into 6 is 3. So this gives us 2 over 3. Now let us try the second method and see if it gives us the same answer. We multiply up and down of every fraction by the denominators of the other 2 fractions. So it will give us this. As you can see, we multiplied 1 over 2 by 3 times 6 up and down. We multiplied 1 over 3 by 2 times 6 up and down. And we multiplied 1 over 6 by 2 times 3 up and down. If we simplify further, we will get this. Now, this is exactly what we want. All the denominators are the same. We can now go ahead and solve across. So this is 18 plus 12 minus 6 over 36, which now gives us 24 over 36. If we simplify it, it gives us 12 here 2, 12 here 3. So the answer is 2 over 3, which is still the same answer we got previously. Now what do you notice in these 2 methods? This second method is longer and takes us through a lot of calculations and big numbers compared to the first method. But this second method will come in very, very handy when we enter algebra. So the advice is always stick with the first method when you are dealing with simple arithmetic, simple fraction simplification. And if you know the LCM, by all means use the first method. but this second method is what we use for algebra and more complicated fractions where we cannot find the LCM. Now, let us go into algebraic fractions. So what is an algebraic fraction? An algebraic fraction is a fraction that has a variable, that is a letter, whether in the numerator or the denominator, like 3 over x, x over 3, or even something like 2x over 5y. So once a letter is involved in a fraction, then that fraction is an algebraic fraction. If you had something like 2 over 3x, where the x is just beside the fraction, you are not sure if that x is up or down. By default, this is 2x over 3. So whenever you see a variable beside a fraction, that variable belongs to the numerator, not the denominator. This is a standard for you to know and remember, because it is very important when you are going to solve. If the variable is explicitly stated below, like with this 3 over x we have, then it's a different matter. It's a totally different term compared to if it was above. So please make this careful distinction because you need it in solving algebraic fractions. Now let's go to simplification of algebraic fractions. We will start with multiplication and division. There's really nothing more to say about multiplication and division. Everything we need to say has been said in lesson 4 of this series. So if you've not seen it, you can go back and check it. But just as a reminder, if you had something like this, 3 plus x over 6 plus x, you cannot cancel 3 and then 6. That would be very wrong because plus is involved here. The numbers are involved with plus something, and plus is not part of the multiplication family, remember. So you cannot cancel out when there's another operator family like plus involved. This is just a reminder. However, if you had something like this, 3 plus x over bracket 6 plus x and then bracket again 3 plus x, you can cancel 3 plus x up and down simply because 3 plus x is a unit that is multiplying 6 plus x. Remember the previous lesson on removing brackets, we explained that brackets beside each other means that they're multiplying themselves. So if you feel uncomfortable with the numerator where we have 3 plus x without a bracket, you can still put your bracket here. It makes no difference. If you've watch the previous lesson on removing brackets, you understand that this is also correct. So you can cancel 3 plus x out up and down because they are a unit now. You are not cancelling the individual numbers, you are cancelling them with their brackets because this is now in the multiplication family setting. This is multiplying this bracket is multiplying this bracket below, and then above you have 3 plus x as a unit that is exactly identical to one of the units below, 3 plus x, which is multiplying another bracket. But if this was 6 plus x bracket plus 3 plus x bracket, then you can no longer cancel because the addition family is now involved. You can see how everything is making sense by just knowing these basics of operator siblingship and operator families. The last thing that we are going to introduce here in this particular section when we are talking about multiplication and division of algebraic fractions is this idea or concept that the denominator can divide the numerator even if there is a plus involved in situations like this. So this is what I mean. 3 will divide 3 1, but that 3 must go through 6 and 3 at the same time. So if it goes through 6, it gives us 2. If it goes through 3, it gives us 1. Then we can write the balance. 2 plus 1 gives us 3. Then underneath we have 1. So the answer here is 3. If you want to verify your answer, you can. 6 plus 3, 9. 9 divided by 3 is 3. So you see you got the same answer. Now let's look at the algebraic version of it. X can divide x squared and still divide 3x at once. It will not divide one and leave the other. So if x cancels x squared, it will remove the squared and leave the x behind. If it cancels 3x, it will remove the x and leave 3 behind. So you have x plus 3 as your answer. So the whole concept of why this is possible is because if you remember the LCM method when we were talking about addition and subtraction of basic fractions, we were able to create a common denominator using LCM and then did that manipulation we did to get a new numerator. That's the same principle we are using. That same common denominator that is dividing fractions can still divide them individually provided it divides everything across. You cannot divide one and leave the other. So that's the whole idea of this concept. We will look at this concept in more details when we get to the next series, which is Intermediate Algebra in Full, where we talk about things like factorization and so on. But it's just important for me to mention this here for now. Now, for addition and subtraction of algebraic fraction, recall that if we had x plus x, for instance, from lesson 3, this gives us 2x because they are like terms, you can add them. And if we had x plus y, you can't add any further, it stops here. But in fractions, the focus is not really on whether they are like terms or unlike terms. The focus is on the denominator. Look at this example now, 1 over x plus 1 over x. Now, from what we've learned so far, the denominators are the same. The denominators will always be the focus when you are looking at adding or subtracting fractions, not whether they are like terms or unlike terms. It's even actually difficult for you to tell if they are like or unlike sometimes because the variables can be mixed into so many places, up and down, numerator, denominator, that it will be difficult for you to track which are like and unlike. So the focus is on the denominators. For you to add and subtract, the denominators must be the same. So in this example, 1 over x plus 1 over x, from what we've learned so far, the denominators are the same. So this gives us 1 plus 1, 2 over x. We pick one of the denominators and that becomes the answer. Now look at this example to understand what I'm saying, that the focus is not on whether they are like terms or not. Now ordinarily, if these were not fractions, if this was x and 2x that are adding, we can just say the answer is 3x because x and 2x are like terms. But this particular terms are not x and 2x. This is 1 over x and 1 over 2x, which are completely different terms from x and 2x. So to add this, we know that the denominators are not the same, but they have a common multiple, which is 2x. 2x is a common multiple because we know that x can divide 2x without any remainder, and 2x can divide 2x obviously. So we will use 2x as their common denominator, then do the same LCM method. X will divide 2x to give us 2, then 2 times 1, 2, plus 2x will divide 2x to give us 1. 1 times 1 is 1. So this gives us 2 plus 1, 3, over 2x. Now this x still remains in the denominator. It is not equal to 3x over 2 or 3 over 2x. It's not the same thing. Please remember, we said that when we started simplification. So you see how adding and subtracting algebraic fractions differ from adding and subtracting whole numbers in algebra. It is important to remember this. Pay careful attention so that you don't mix up fractions and whole numbers. Now look at this example, 1 over x plus 1 over y. If this was x plus y, we will stop there. We can't simplify any further because they are unlike terms. But in fractions, like I said, the focus is on the denominator. We get a common denominator by multiplying x and y. This is what we said when we were talking about basic fraction simplification. So we go the same approach. Xy divided by x gives us y. Y times 1 is y, plus xy divided by y gives us x. X times 1 is x. This is where we will stop because we've gotten to that stage where y plus x we cannot add because they are unlike terms. So the answer becomes y plus x over xy. This is the same thing as this if you want them to have a common denominator. Otherwise, you just leave it the way it is, 1 over x plus 1 over y. This is also an appropriate answer that doesn't need simplification. But if you want one common denominator, then you have to use this as your answer. Let us now take some other examples before we wrap up the lesson with try exercises. Now look at this example. As you can see, all the denominators are the same. So we can easily add the fractions, add the numerator. So this gives us, and remember from what we said, the letters will go to the numerator. We've said that. So this gives us 3a. Remember operator ownership. This minus belongs to the 5. Minus 5a plus 2a over 7. So if we simplify further, it gives us 3a minus 5a is minus 2a. Minus 2a plus 2a is 0. So this gives us 0 over 7. 0 divided by anything is 0. So the answer here is 0. Let's take another example. Now look at this second example. 5 over 6a minus 7 over 8a plus 3 over 12a. Now to solve this, we are going to get our common denominator, which will be 24a in this case. Why? Because 24 is a multiple of 6a 8, and 12. And then a is also a multiple of all of them since all of them have a. So we continue the usual way. 6a we go into 24 to give us 4. Because a we cancel a, then 24 divided by 6 gives us 4. This is why it's important to know the things we learned the previous lessons before getting to this one. We talked about how to multiply and divide algebra. So that 4 multiplied by 5 gives us 20. Minus 8a will go into 24 to give us 3. 3 times 7 is 21. Plus 24 over 12a will give us 2. Then 2 times 3 is 6. If we simplify this further, it gives us 20 minus 21 is minus 1. Minus 1 plus 6 is 5. So this is 5 over 24a. And that becomes the final answer. Let's take another example. Look at this example on your screen. 3 over 4ab minus 5 over 6ab plus 7 over 12ab. As usual, we will find the LCM first. What is the LCM? 12ab. Because 12 is a multiple of both 4 and 6 and 12, and then AB is common amongst all of them. So we do the same thing. 12AB divided by 4AB gives us 3. 3 times 3 is 9. Minus 12AB divided by 6AB gives us 2. 2 times 5 is 10. Plus 12AB divided by 12AB gives us 1. 1 times 7 is 7. So this gives us 9 minus 10 is minus 1. Minus 1 plus 7 is 6 over 12ab. Then if we simplify it further, 6 here 1, 6 here 2. So this now gives us 1 over 2ab. And that becomes the final answer. Let's take another example, the last of this lesson. Now this particular example is a classic case of how all the lessons combine. These are brackets here that we need to remove. And we did removing brackets in the last lesson. So let us apply that skill first and remove the brackets. Then we can now simplify the fractions. Remember what we said. The inner brackets go first. So this gives us 1 over 3, bracket open, 6x. Then this minus 3 over 2. To open the bracket with x minus 4. Remember what we said. Minus 3 over 2 times x. Based on distributive law, this will multiply this. And then this will multiply this. So this gives us minus 3x over 2 or minus 3 over 2x like we said. Remember we said when you have a variable that is not indicated as being up or down, then that variable should go up. You should put it up. That's why we said minus 3x over 2. Then minus 3 over 2 times minus 4 gives us plus 12 over 2. Then we put this other bracket plus, now to open this bracket, 1 over 4 times 8 gives us, I'm not cancelling out yet because I don't want to cause confusion. So let's just continue like that. Let's multiply it directly first, then we talk about cancelling out later. So 1 over 4 times 8 gives us 8 over 4. Then 1 over 4 times minus x over 2 gives us minus x over 8. Now we have one more bracket to take off. So 1 over 3 times 6x gives us 6x over 3. Then 1 over 3 times minus 3x over 2 gives us minus 3x over 6. Then 1 over 3 times 12 over 2 gives us plus 12 over 6. So that's all the brackets gone. Then we put these other ones plus 8 over 4 minus x over 8. Now let us cancel out or simplify the fractions individually. So let's start from left to right. 3 here 1, 3 here 2. 3 here 1, 3 here 2. Don't forget this minus here. 6 here 1, 6 here 2. 4 here 1, 4 here 2. Writing it out now, what is left will give us 2x minus x over 2, that is this minus x, I'm not leaving the minus behind, plus 2 minus x over 8. So this is the same thing as 2x over 1. I'm trying to make it a fraction to match up with other fractions so it will be easy to solve. Minus x over 2 plus 4, that is 2 plus 2 is 4, over 1, we make the 4 over 1 as well to make it easy to solve. Then minus x over 8. Now we have all of them looking like fractions. Now to solve it, we'll get the LCM again. LCM has to be 8 because 8 is a multiple of all of them, 1, 2, and 8. So same way, 8 divided by 1 is 8. 8 times 2x is 16x. 8 divided by 2 is 4. 4 times minus x is minus 4x. Then 8 divided by 1 is 8. 8 times 4 is 32 plus 32. Then 8 divided by 8 is 1. 1 times minus x is minus x. Now collecting like terms gives us 16x minus 4x minus x plus 32 all over 8. If we simplify further, this gives us 16x minus 4x is 12x. 12x minus x is 11x. So this is 11x plus 32 over 8. And that becomes the final answer. Now, if you prefer to have whole numbers or you prefer to have the fractions separated, you could also rewrite this as 11x over 8 plus 32 over 8. I explained this when I was talking about when the denominator is dividing the numerator, even if there is a plus there. The denominator has to make sure it divides all the numerator one by one. It must not divide one and leave the other. So with that, we can rewrite this expression as 11x over 8, that is the 8 dividing one of the terms, and then 32 over 8, that is the 8 dividing the second term. So this can now go on to give us 11x over 8. 8 divided by 1 is 8. 8 divided by 32 is 4. So this gives us 11x over 8 plus 4. So this is another appropriate answer. Either of them is correct. Here are the try exercises to solidify your skills. They are in levels, and these levels are identified by their color codes. Use the description to know what the color codes mean if you don't know that already. As usual, we will release the solutions to the try exercises, but try them first. Check our website mathinfo.com to get so many more exercises like this to make your confidence even better. The next lesson is going to be on order of operations, which is a very vital tool you must know in algebra and in mathematics generally. So this is a wrap on today's lesson, which is lesson 7 of the basic algebra and full series, Algebraic Fractions. Keep studying, and as you do, remember, in mathematics, it's all connected.